We have created short videos to summarize a book entitled Learning the Brainstem. The voice you hear is AI generated, as clear in diction as we can make it. LTB16 transitions from low medulla to spinal cord. In the inset photograph to the left, which I borrow from LTB15, I remind you that if we drew a line passing from the lateral edge of dorsal motor nucleus of vagus, marked by the pink dot, just past the solitary tract and its nucleus, marked by the white arrow, we identify a sulcus limitans that usefully divides nuclei. The yellow line indicates the sulcus. Motor nuclei are medial to the sulcus and sensory nuclei are lateral to it. In the large image to the right, we are in low medulla, lower than the level of the inset image. We do not visualize principal inferior olivary nucleus well in the left hemimedulla. The fourth ventricle is closing or becoming more constricted, as the blue triangle suggests, and the floor of the fourth ventricle just looks different from what we see in the inset image. The right image is the same as the large one in the last slide. Note where CN12 nucleus is. I mark the left CN12 nucleus with a white dot. It is no longer at the floor of the fourth ventricle. I identify the solitary nucleus and its tract, or the nucleus tractus solitarius, in the left hemimedulla. I mark it with a yellow arrow. As the fourth ventricle narrows, as the CSF space transitions to the central canal of spinal cord, a so-called vagal trigon is what we see nearest the midline on either side. Since the vagal trigon was first described in the late 19th century, I include a diagram from that time to the left. The shaded red triangle is the area of the vagal trigon which includes the dorsal motor nucleus of vagus. But the lateral aspect of the vagal trigon includes the so-called area postrema, which is free of the blood-brain barrier and is involved in generating a vomit response. I cannot be sure that I am not seeing area postrema in the shaded rectangle in the axial section in left hemimedulla. Suffice it to say, however, that in low medulla we visualize nuclei that we have not seen previously. 3 new nuclei are of interest. In the left hemimedulla, the blue dot sits in nucleus gracilis, the yellow dot sits in nucleus cuneatus, the orange arrow points at the lateral cuneate nucleus, which is the rostral equivalent of Clark's nucleus in spinal cord. Fibers arising from lateral cuneate nucleus transmit dorsal spinal cerebellar information to the ipsilateral inferior cerebellar peduncle en route to ipsilateral cerebellum. Gracilis and cuneatus fibers will pass to the contralateral medial lemniscus, where leg representation is ventral to arm representation, as the blue and yellow dots on the headless person's left hemibody indicate. Passage across the midline happens by way of internal arcuate fibers. We have seen the descending or spinal tract and nucleus of CN5 previously. I place a red dot on it. In the midline, ventral to the hypoglossal nucleus, which we mark again with a white dot, we see MLF, immediately ventral to the nucleus, then tectospinal tract ventral to MLF, but dorsal to the medial lemniscus. As the fourth ventricle closes, we can start to think about a lamination pattern relevant to the descending spinal tract of CN5. Roughly at our current axial level, all of the left hemiface sensory divisions, V1, V2, and V3, will be represented. But the entire hemiface is not represented. We start in the middle face, around the nose. As we descend lower or caudally, even into cervical cord, the amount of facial representation enlarges concentrically. Remember, the representation of the central face, in light orange, is highest almost rostral. Note that in the left descending spinal tract and nucleus of CN5, the left face is represented, and the pain and temperature information carried in the spinal tract and nucleus will cross the midline at various levels of medulla towards the contralateral anterolateral system, which ascends. This image is a bit lower than the last axial cut, where we saw a bit of the inferior olive in the right hemimedulla. Note that midline nuclei that we have encountered are now essentially enveloped. A white dot sits in left, CN12 nucleus. The arrow points to left dorsal motor nucleus of vagus. The arrow points to the nucleus of the solitary tract, which actually straddles the midline at this level. A bit of the tract of solitary nucleus is present on the right side of the midline. Blue, yellow and red dots indicate nucleus gracilis, blue, nucleus cuneatus, yellow, and the descending spinal nucleus of CN5, red. The midline white arrow passes between MLFs, tectospinal tracts, and a nascent medial lemniscus on either side to point at the anterior median fissure, which has not yet been effaced by the decussation of the pyramids. The image furthest to the left is highest, and we pass to lower axial sections across the screen. The grey circle indicates the beginning of the decussation of the pyramids, which continues in all the images. The anterior median fissure is no longer present by the image furthest to the right. Of the three preceding images, I draw attention to this one, which illustrates best how in the ventral low medulla, the areas indicated by white squares are populated by motor neurons that contribute to the accessory spinal nerve, or CN11. Note, however, that anterior horn cells of upper cervical segments also contribute fibers to CN11. And with that last comment, LTB ends, save for one last video, in which we address arterial supply of the brainstem as a whole. As always, thanks for watching.